Yes. So in your last class in GOC we introduced what is concept of hybridization with the variable applications, how carbon-carbon, single bond, double bond, triple bond will show variable overlaps, and what kind of hybridations are possible for carbon and what are not possible, and everything we discuss regarding hybridization. Okay, so few questions we discuss, take few more, then we'll see what is additional concepts which are linked with hybridization. Right. Right on. The hybridization ratio, involving diallyl is, what is the hybridization ratio involving diallyl? 1:1, B 2:1, 2:2, option D 3:1. What is the hybridization ratio involving diallyl is? Diallyl carbons are given, diallyl skeleton. So you need to find out the hybridization of sp2 carbon as well as sp3 carbon. So diallyl are given. So here I am clearly mentioning sp2 as well as sp3. This is hybridization ratio you need to calculate. So in this diallyl sp2 sp3 carbons are present. What is the hybridization ratio involved in this one? sp2 sp3 ratio we need to find. Okay, so what is a diallyl here? Two allyl carbons are connected together, so this is called allyl. This is allyl. Suppose if this unit repeat one more time, that is called diallyl. So I am repeating this unit. This is CH, carbon carbon double bond, this one. So what about this carbon? sp2, here sp2, and what is this? sp3, sp3, here sp2, and here also sp2. How many sp2 carbons? 4 sp2 carbons. And how many sp3 carbons? 2 sp3 carbons. If you divide by 2, here you will get 2. 2 sp2 carbons, and what is one more? Here 1 sp3 carbon. So finally what is the ratio? 2:1. So that is 2:1. Like that. So like that hybridization ratio questions also you can expect. Part B questions there. So they will give one hydrocarbon skeleton. Common name they will give. After giving common name, you try to identify the type of carbons. What type of hybridization is involved in that one? Either sp2 or sp3 or sp3 like that. So this they will give clearly. So otherwise based on the ratio we need to find out the answer. Clear? This is called diallyl. So up to here it is called allyl. This part is allyl, and if I repeat, diallyl. Clear? How many sp2 carbons? 4. How many sp3 carbons? 2. 4:2. Divide by 2, 2:1. Clear? So this is called divinyl. You remember this name? Divinyl. Here two triple bonds are connected. This is a diacetylene. And here double bond connected to triple bond. This is called vinyl acetylene. Vinyl acetylene. Okay. So suppose if two vinyl units are present, here carbon carbon triple bond, and here carbon carbon double bond. So this is vinyl, here also vinyl. Middle is what? Triple bond. That is called acetylene. So I can say divinyl acetylene, divinyl acetylene. This is one vinyl part, here one more vinyl part, and this is acetylene part. So write down the hybridization and their ratio. So what is this carbon? sp2, and here also sp2, here sp2, and here it is sp2. Only sp2 carbons are present. You remember that name, divinyl. And here sp, 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 and here sp. Here sp2, sp2, sp, sp. 1:1 ratio. 1 sp2, 1 sp. 1:1 ratio. Now here sp2, sp2, sp, sp, and here also sp2, and here sp2. 2:1 ratio. So what is the 2:1 ratio here? sp2, 4 sp2 carbons are there, 2 sp carbons are there. 4:2 means 2:1 if you divide by 2. Okay, like that, these names you need to remember. So they may ask sp2 carbon, sp3 carbon. Whatever carbon hybridization is there, that they will give in box over here. Clear? Suppose in this any sp hybridization is there? sp? No. Here any sp2? No. They won't ask that sp2. Otherwise they will give sp2, sp3, or sp2, sp, 2:1, 4:1, 0, 4:0, 2:0, like that question they will frame. Clear? Right. Next one. So I'm taking one molecule, the variable overlaps. The variable overlaps involve in following molecule. What are the variable overlaps involved in following molecules? I'm going to give one molecule. In that molecule, try to identify the variable overlap, different overlaps. Okay, so this is that molecule. Here double bond, and this is a triple bond. In this molecule, how many different overlaps are present, that you need to calculate. I'm not asking total number of overlaps. How many different overlaps? If I say the word variable, try to write the different overlaps. Carbon, carbon, carbon hydrogen, sp2 carbon hydrogen, sp2 carbon and other carbon hydrogens. Okay, so try to identify the different overlaps involved in that one. So what is the carbon? sp2, and here sp2. What is this? sp3, sp, and here sp. So can I say in this there is a presence of sp2, sp2? sp2, sp2 overlap is there? Yes. There is a presence of sp, sp. sp, sp overlap is there? Yes. Then third one, there is a presence of sp, sp3 present. sp, sp3 present. Then we can also go for sp2, sp present, sp2, sp3. sp2 sp3. Any other carbon carbon overlap? Any other carbon carbon overlap is present? No, only 4 possibility: sp sp, sp2 sp2, sp3 sp, sp3 sp2. Total 4. Then any other? Can I expect sp3s overlap? sp3s overlap. It is there or not? This one, sp3s. Then followed by sps overlap is present. Then one more is sp2s overlap. sps overlap. Here hydrogen is there. And here this is no hydrogen. Here hydrogen is there. sp3s. And here also hydrogen. sp2 yes. Total how many variable overlaps? 7 different overlaps are present. Clear? So so take this molecule and give the answer. Now in this how many carbon carbon overlaps are present? Only carbon carbon or carbon hydrogen even. So there is a presence of sp2 sp2. There is a presence of sp3 sp2 is there or not? Any other carbon carbon overlap? Fast. That's why I'm saying by watching the carbon you are in a position to say the type of hybridization. Then only you will get the answer. sp2 sp2, sp2 sp2, sp3 sp2. Any other carbon carbon overlap? No, only 2 different overlaps. So can you expect sp3s overlap? Can you expect sp2s overlap? sp3 sp2. Okay, next. See, I am writing a double bond and here triple bond I am writing with proper separation. How many different overlaps are expected? Work out this. Only carbon carbon or total overlaps you are saying? Total I am asking. Total variable overlaps. In this how many you are getting? 7. You will get more than 7. Can you expect SP-SP? Is it SP-SP or not? SP-SP, SP2 SP2, SP3 SP3, SP3 SP, then SP3 SP2. Total carbon overlaps are how many? 5. 5 carbon overlaps you are getting. Up to here it is remains same. Additionally SP3 SP3. Clear? Then remaining 3 are common. SP3S, SP2S, SPS. This is SP2S, SP3S, SPS. Total 8. Mostly they won't ask total number of overlaps. They will ask different overlaps exist in given molecule, like that. So this you work out as homework. Here, two double bonded carbons I'm writing. So this is a triple bond, and here also triple bond. Take down these two examples. One comma three butadiene. This is 1,3 butadiene. Here how many carbons are present in this one? This molecule carry how many carbons? 1, 2, 3, 4, 5 and 6. Total 6 carbons. Clear? Clear? So take down that as homework. You work out later. Just leave it. Clear? See. Which of the following overlap? Does not exist in propadiene. In propadiene, which overlap is not exist? I am asking. sp2 sp b sp2s sp2 sp2. Option D, all. Which overlap is not exist? Propadiene name I given. That name, with respect to that, you need to write the structure. So after writing the structure, write down the hybridations involved in individual carbon, then see the overlap. Which overlap is not exists, that you need to select among these three. Answer is C. Because two sp2 carbons are get separated by C. One sp carbon. This is sp2 or not? sp2 carbon, and here also one sp2 carbon. This is sp. Two sp2 carbons are separated by sp. So that I can say that there is no sp to sp2 overlap. Is this two sp2 carbons are connected together? Is this two sp2 are connected? No. So answer is this is not present. sp to sp is there or not? sp to sp. And this carbon nitrogen is what? sp to s. And here this is also sp to s. There is no sp s overlap in this one. It is same way. This carbon gets separated two sp2 carbons. Clear? So keep heading. Hybridizations involve in inorganic molecules. How to calculate hybridations in inorganic molecules? Hybridizations involve in inorganic molecules. Hybridizations involve in inorganic molecules. See, if I take N nothing but neutral, there is no charge. N nothing but neutral, no charge in a inorganic molecule. So, group number of monovalent divided by 2. This is a formula. What is G indicates? Group number. Carbon group number is 4. Nitrogen 5. What are monovalent? Having only one valency, such as hydrogen and halogen. Clear? So, suppose if it is a cation, group number plus monovalent minus, here it is charge on cation. Here you remember charge on cation by 2 divided by 2. This is the formula. Okay. Suppose if it is a means what? Anion. Group number of monovalent, then plus, here I am writing charge of anion. What is the charge of anion? You need to write, and finally divided by 2. So you need to remember these formulas to calculate hybridizations of inorganic molecules. So what about G? G indicates group number and M indicates monovalent. Can you give an example of monovalent? Hydrogen and halogen. Hydrogen and halogen having one valency. What is valency? Combining capacity of any element is called valency. What are valence electrons? Outermost electrons for any atom or molecule is called valence electrons. Valency means how much they capable. Ability to form number of bonds is called valency. Okay. So hydrogen valency is what? 1. Halogen valency 1. Carbon valency 4. Nitrogen valency 3. Oxygen valency 2. This is called valencies. Valence electrons 1, valence electron 7, valence electron 4, valence electron 5, valence electron 6. They are called valencies. Valencies of variable elements. Okay. So what about N indicates? Neutral. C indicates cation, positive. A indicates anion. Suppose if I take one example, xenon difluoride I am taking. How many monovalents are present in this one? 2 or not? What is the group number of xenon? 8. How many monovalent? 2. 8 plus 2 by 2. Then what is your number? 4. 4 or 5? That is 5. 8 plus 2, 10. 10 by 2, 5. So what is 5 indicates? Whenever if you are getting number 2, 2 indicates sp, 3 indicates sp2, 4 indicates sp3. So you add this number. So 5 indicates what is hybridization? sp3d, 3, 4, 5 like that. Suppose if I take xenon tetrafluoride, so 8 plus 4 by 2 or not? Then what is your answer? 12 by 2. 12 by 2 means 6. 6 means what is hybridization? sp3d2 like that. You count these orbitals total. Total number of orbitals become this number. Suppose xenon hexafluoride if I give xenon 8 plus 6 by 2. How much? 7. Okay. So 7 means what is hybridization? sp3 d3. Suppose if I take xenon trioxide xenon trioxide, xenon tetroxide, okay, xenon dioxide. Then what is your answer? Xenon trioxide. Here how many monovalent here? Formula. Group number plus monovalent. Group number for xenon 8. How many monovalent? 0 by 2. Don't consider oxygen, because oxygen is a divalent or bivalent. So how much you will get? 4 or not? When you get 4 means what is the answer? sp3. Xenon hybridization in xenon trioxide is sp3. What about this one? Same or not? Don't consider oxygen, ignore oxygen. So everywhere you will get same answer. So here also sp3, sp3, sp3. Clear? Right. G nothing but group number. Which group element? First, second, third, fourth, like that. You just remember the group number. Group number M nothing but monovalent. Means valency will be 1. So here M nothing but either hydrogen or halogens. M nothing but either hydrogen or halogen. Suppose if hydrogen halogen is not there, M should be taken as 0. See this one, any hydrogen halogen is there? No, that's why taken 0. Here how many monovalent is there? 6. 6. Here 4. Here 2. So take these examples. Xenon oxidifluoride, diaxidifluoride. Next ICl, ICl3, BRFI, IF7. So BR2. HClO4, HCl4 perchloric acid. H2O, sulfur dioxide, sulfur trioxide, S4Cl2. SF6. This you take in as homework. First you write down the molecules, work out later. Few I will explain directly. Because same concept is same, you identify which element is a central element. Which is central element here? Xenon. Here iodine, bromine. Iodine, bromine, chlorine. Chlorine we are calculating. Okay? So here oxygen, sulfur, nitrogen, phosphorus, carbon. This is SiH4 and this is silicon dioxide. It is exception. This is borane, alane, beryllium dichloride, magnesium dichloride. So all neutral molecules are given. Just you find out the hybridations based on the number. Silicon dioxide is exception. So your calculated number, observed number is not same. Ignore this. I will explain this one. Remaining all you follow the general strategy. Will you find out this? So here see 8 plus 2, 10, 10 by 2. So 10 by 2 means 5. So 5 means what is hybridization? sp3d, like that. Only monovalency group number. Here see 8 plus 2, 10, 10 by 2, 5, sp3d. Here 7 plus 1, 8 by 2, 4. Will you work out this? 7 plus 3, 10, 10 by 2, 5. Here 7 plus 5, 12 or not? 12 by 2, 6, sp3, d2. So will you work out remaining all? Here one halogen should be taken as reference, other should be taken as a monovalency. 7 plus 1, 8. 8 by 2, 4, sp3. So in this chlorine just you consider group element 7 plus 1, 8 by 2. 8 by 2 means what? 4, sp3. So what about NOCl? Nitrogen 5. 5 plus 1, 6. 6 by 2. 6 by 2 means 3. 3 means sp2. Clear? Is it easy? What about carbon dioxide? Carbon hybridization is sp or not? sp. See, carbon 4. Any monovalent? No. 4 by 2, 2 sp. Methane, this is well known, sp3. 4 plus 4, 8. 8 by 2, 4. 4 means sp3. This is well known already. We discussed about single bonded carbons. Now what about here? Silicon, which group? Fourth group. 4 plus 4, 8. 8 by 2, 4. sp3. It is sp3. 8 by 2 means 4. Hybridization is sp3. Here silicon, remember, it is sp3 because it is exists as a sheet structure. It is a real structure of silicon dioxide. Silicon dioxide don't apply. Silicon 4 by 2, 2 sp. Don't write sp. Hybridization is sp3. Silicon dioxide never exists in monomeric form. Always in a polymer. Polymer sheet type of structure. Every silicon dioxide gets surrounded by 4 oxygens. But generally we will take it as SiO2. In exam, if SiO2 is given, don't write sp. Be careful. Don't write 4 by 2, 2. Write down sp3 because it is a sheet type of structure is present. Silicon. So this is exception. Most important. Even in CSR also this question is given. CSR examination. What is the hybridization of silicon dioxide? Silicon in silicon dioxide. Xenon trifluoride plus xenon dioxyfluoride plus xenon trioxy plus 2. ICl2 plus BrF4 plus you know I3 plus, this is important one, I3 plus. So oxygen H3O plus NH4 plus PCl4 plus carbocation CH3 plus now work out with anions. BH4 minus AlCl4 minus carbanion CH3 minus. So NH2 minus amide, and this is imide NH minus. This is NH minus. Okay, you know NO3 minus 1 comes from nitric acid, NO2 minus 1. PCl4 minus. If negative charge is given, add electron. If positive charge is given, remove electron after group number. Very easily you will get the answer. Just try this. So what is hybridization present in silicon? In silicon dioxide? Sp silicon dioxide, sp3. It is not sp. Silicon dioxide, if I given silicon fourth group element 4/2, then you will see you will get sp. That is wrong. Some molecules we are writing based on the original existence. Okay, silicon dioxide, very very important example. I3 minus ICl2 minus BrF4 minus IF6 minus. ClO4 minus 1 like that we can calculate most of the negative ions involved in inorganic compound as well as positive ions involved in inorganic compound. Anywhere you can calculate. Blindly we can calculate without applying VSCPR. So generally we will apply VSCPR for the structural determination, but before that you have to know about what is the actual hybridization involved in a given molecule. So first you start with this cation, xenon difluoride with positive charge. Xenon belongs to which group? 8th group. Okay, 8 plus 3. 8 plus 3 level minus 1. 10. 10 by 2. 5. So 5 means what is hybridization? sp3d. Like that we need to calculate. And here also same. 8 plus 1. 9. 9 minus 1. 8. 8 by 2. 4. So 4 means what is hybridization? sp3. At last try to remove that. Formula remains same. Group number plus monovalency minus charge of cation by 2. Okay. So what about here? Group number 8. 8 minus 2 or not? See, this is 8. There is no monovalent. 8 minus 2 by 2. So means how much you will get? 6 by 2. 6 by 2 means 3. So what is hybridization? sp2. If plus 3 is there, minus 3 you need to add. Means 3 electrons we need to remove. Will you work out remaining all? See, this is important one. What is the hybridization of I3 plus? How many iodines are present? 3. One iodine is middle or not? One should be taken as reference. Remaining 2 are connected to that iodine. So one iodine is 7. Plus how many monovalent other than 1? Remaining 2 are there. That is 2. Plus 1 is there. Write down minus 1 by 2. 9 minus 1, 8 by 2, 4, sp3. Clear? So generally what you will do, you will write 7 plus 3 you will write, because 3 iodines are there. You will get wrong answer. If one iodine is taken as a reference, if one iodine is middle, what about remaining 2 iodines? They are surrounded iodines around the central iodine. Right or not? Okay, so will you work out this? What is the hybridization of oxonium protonated water? Is it 6 or not? 6 plus 3. 9 minus 1. 8 by 2. 8 by 2. 4. So 4 means what is hybridization? sp3. Oxygen is 6. 6 plus 3, 9. 9 minus 1. 8. 8 by 2. 4. sp3. Clear? Will you work out all? Same way you work out. What about NO2 plus? NO2 plus. 4 by 2 sp. Linear. 4 by 2 sp. Carbocation. 4 plus 3, 7. 7 minus 1. 6. 6 by 2. 3 sp2. Is it clear? So you work out this all. Go through anions. So BH4 minus NaBH4, you know, NaBH4, sodium borohydrate, in that negative ion. Boron belongs to which group? Third group. 3 plus 4 plus 1 by 2. 8 by 2 or not? 8 by 2, 4. sp3. And here also same. Carbanion. 4 plus 3, 7 plus 1, 8 by 2. sp3. This is called amide. Amide. Will you work out all? So work out remaining all examples. They are very easy. What about NH minus? Minus 2 it is, not minus. NH minus 2. Imido. This is 5 plus 1 plus 2 by 2. 8 by 2. And here also same or not? See, 5 plus 2 plus 1 by 2. 8 by 2. 4 sp3. Right? Here nitrogen. What about in this case? 5 plus 1. 8 by 2. Here NO2 minus. Sorry, it is 6 by 2, not. It is also 6 by 2 or not? 5 plus 1, 6. Phosphorus belongs to which group? 50 group here. 5 plus 4. 9. 9 plus 1. 10 by 2. 5. If minus 2 is there, add 2 electrons. Minus 3 is there, add 3 electrons, like this, simple. I3 minus, it is also important one, I3. Can you get? Iodine, central element. 7 or not? It is 7. 7 plus, how many remaining iodines are present? 2. 2 plus 1 by 2. 10 by 2, 5. Right? So what is the meaning of minus? 1 extra electron. That's why 1. 1 we are adding. Minus 2 means 2 extra electrons. ClO3. Will you work out ClO3 minus? Chlorine. 7th group element. No monovalent. Extra electrons are 1 by 2. 8 by 2. sp3. 4. So you will get here sp3 or not? 7 plus 1. 8 by 2. Here also 8 by 2. So this all having same calculations. See. 7 plus no monovalent 1 by 2. And here also 7 plus no monovalent 1 by 2. And here also same. 7 plus 0 plus 1 by 2. So this is called perchlorate ion. Chlorate ion. Chlorous ion. This is called hypochlorous ion. Sulfato comes from sulfuric acid. SO4 minus 1. Sulfur belongs to 6th group. And here how many extra electrons are there? Extra electrons are 2 by 2. 6 plus 2 by 2. 8 by 2, 4. Sulfuric acid, you know, sulfuric acid. H2, H2SO4. What is this molecule? This molecule is SO4 minus 2. Sulfur belongs to 6th group. 4 oxygens are there. No monovalent. Minus 2 means plus 2. Clear? It is coming from which acid? Sulfuric acid. Here also same. You will get same answer. Right or not? You will get same answer. It is a direct method to calculate number of lone pairs and the number of hybrid orbitals present in a given central atom in a molecule. Okay? It is a direct method to calculate only hybridizations. For organic molecules, number of sigmas, number of lone pairs. If any lone pair is delocalizing, we need to ignore it. For inorganic molecule, group number plus monovalency by 2. If cation, group number monovalency minus charge present on cation by 2. If it is anion, plus charge present on anion by 2. Clear? Next. Linearity and planarity. Linearity and planarity. So up to now we discussed how to calculate hybridization of total organic and inorganic molecule. Now we need to identify whether it is a linear molecule or planar molecule. So what is a linear molecule? Linear molecule is like this. It is a linear. All atoms present in this molecule will lie on imaginary axis. Suppose if 3 atoms are present, 1, 2, 3, and if I pass one axis, that axis should touch each and every element or atom present in a molecule. The total number of atoms present in a molecule will lie on imaginary axis. That is called linearity. What is planarity? All atoms in a molecule will touch on a surface of a plane. Suppose one molecule having 4 atoms. One molecule having 4 atoms, methane. If I leave on surface, whether 4 atoms are touching on the surface or not, that is called planar. Suppose if any molecule having 10 atoms, If you leave that molecule, 10 atoms are present. 10 atoms consisting molecule should touch on surface of a plane. Then only that molecule is said to be planar. Right? Planar nothing but complete body should touch on surface of a plane. Clear? 2 points you need to remember. Linear nothing but the total number of atoms in a molecule should touch on imaginary axis, should lie on imaginary axis. Means if I pass one axis, they should touch each and every atom present on a molecule. Suppose planarity, if I want to define what is a planarity, each and every atom in a molecule should touch on surface of a plane. If I leave it, if any one of the atom, if it is not on a plane, if it is not touching on the plane, if it is out of the plane, then that molecule is said to be non-planar. Linear nothing but completely straight line, like this it is a linear. Planar nothing but this one. See my hand, this surface will contact on the surface clearly. Okay, then this is said to be planar. So remember, every linear molecule is planar. If I say the word linear, remember that is 100% planar. But if molecule is planar, may or may not be linear. Every linear molecule is planar, but every planar molecule may or may not be linear. Because see, this is linear or not? If I touch here, each and every atom touching the plane. Okay? Suppose if it is a planar, it may not be linear. See, one atom this side, 4 atoms are this side. So can I pass one axis like this? If I pass like this, one atom is completely away from planarity or linearity. So, best example I will show. Listen, if I write carbon dioxide, I can write carbon dioxide like this only. Then if I pass one axis, this is an axis. Each and every atom touching the line or not? If I pass one straight line axis, each and every atom will lie on the imaginary line. Then that atom is said to be, this molecule is said to be linear. Okay? Suppose if I take NO2 plus, now here also remains same. Each and every atom touching the imaginary line. It is also linear. Suppose if I take sulfur dioxide, if I write like this, this is a real structure of sulfur dioxide. Can I say linear? No, it is not linear. See, if I write imaginary axis, this imaginary axis will touch only 2 atoms, either this side or this side. Only one line we need to pass. Don't say, sir, I want to pass many linear axes. That won't be accepted. If I pass one imaginary axis, this is touching oxygen, sulfur, but not this oxygen. So I can say it is a non-linear. It is not a linear molecule. Remember, if I say the word linear, remember it is also a planar. But if I say the word planar, may or may not be a linear. Right or not? What is the difference between linear and planar? Linear molecule means straight molecule, like a pen, like a pencil, like a linear. So molecule, if I represent like a pen or like a pencil, that molecule is called linear. And each and every atom should present on that line only. Suppose a linear molecule having 10 atoms, 10 atoms should present on line. If they carry 20 atoms should present on line. If they carry 2 atoms should present on line. So, what is linearity? The total number of atoms present in a molecule should lie on imaginary axis. That is called linear. So, what is non-linear? Suppose if 10 atoms are present, if at least one atom other than linear. If it is completely deviating out from linearity, that is called non-linear. So 4 points you need to remember: linear, non-linear, planar, non-planar. Clear? Right. First you write the definition. Write down. The total number of atoms in a molecule. The total number of atoms in a molecule present on a imaginary axis. Present on a imaginary axis. Present on a imaginary axis is known as linearity. Is known as linearity. Okay, so you write down this possibility. Sp is linear, sp2 it is non-linear. If molecule having only sp3, non-linear. If molecule having sp2, it is also non-linear. sp2, sp3, it is also non-linear. Only one is possible here now. If any molecule having sp2, sp2, sp3 overlap, it is also non-linear. Only one possibility is linear. What is that? sp. If any molecule having sp hybridization, it is said to be linear. If any molecule having, somebody is calling. You can go. If any molecule having sp hybridization, is it linear? If any organic molecule, if any inorganic molecule having only sp hybridization, that is linear. sp2, non-linear. sp3, non-linear. So now I am taking one molecule, two atoms. One atom having sp, other atom having sp2. Then this molecule is non-linear. Here two atoms in a molecule carry sp, sp3, non-linear. sp2, sp3, non-linear. Okay. If three atoms in a molecule, if you calculate the hybridization, and if they have sp, sp2, sp3, that is said to be non-linear. Clear? So what is the possibility for linearity? Only sp. Right. One more definition for planarity. The total number of atoms in a molecule, should contact on surface of a plane. Should contact surface of a plane. Should contact surface of a plane is known as planarity. See, if molecule having sp, planar. If molecule having sp2, it is also planar. Then what about sp3? It is non-planar. If any molecule having only sp3, non-planar. Only sp2, planar. Only sp, planar. If molecule having sp, sp2, it is also planar. Remember here one exception is there, except alene or propadiene. Except alene or propadiene, remaining all are planar. Okay, so this is non-planar. And here also non-planar. Only these two possibilities are planar. It is also planar, but depends on molecule. Except alene, remaining all are planar. You write clearly planarity. or planar molecule. Both are same. Just make a correction in the spelling. Right? Here write one point. All linear molecules are planar. All linear molecules are planar, but all planar molecules are not linear. All linears are planar, but all planar is not linear. Okay. See, which of the following is linear? Which is linear, I am asking. Carbon dioxide, carbon disulfide, NO2 plus, option D all. Which is linear among these four? Which of the following is a linear molecule? All are linear or not? Yes, all are linear. Here carbon carbon triple bond. Here which of the following is a linear molecule, or we can say which of the following is linear? All are linear or not? Yes, here also all are linear. All are linear. Which of the following is non-linear? What is the answer? A is non-linear. It is a V-shaped molecule. Sulfur dioxide V-shape, it is not linear. Which of the following is a planar molecule? Which is planar? All are planar. Which of the following is planar? Here also all are planar or not? Even though it is a bent shape, it is a planar because all linear molecules are planar. So it is also planar, it is also planar, it is a V-shaped molecule. But still, if you leave this molecule, it is going to touch each and every atom on a surface of a plane. So I can say sulfur dioxide, it is a bent shaped molecule, V-shaped molecule, but still it is a planar. It is not linear. It is a non-linear, but it is a planar. Which of the following is non-planar? Non-planar. B is non-planar. See the definition what I given. First sp is planar. sp2 is planar. sp3 non-planar. sp2 planar or not? sp2 is planar except allene. This is allene. Allene is not planar molecule. This double bond is vertical, this double bond is perpendicular. Vertical, perpendicular, both are not in one plane. So I can say it is non-planar. So one double bond is vertical, other double bond is horizontal. So here hydrogens are right and left. Here hydrogens are above, below. It is impossible to write all atoms in one plane. These carbon hydrogens are above, below. But these carbon hydrogens are right and left. Like a plus symbol. That's why you need to pass a plane like vertical or horizontal. If you pass a plane vertically, horizontal atoms are unable to present on plane. So this molecule is 100% non-planar. Which of the following is non-planar? Same question is remain same. This is first question with this and this is second question. Statement is same. Question framing is same but molecule I am changed. Which of the following is a planar? Answer is what? C. C, all carbons having sp2 or not? C, one point explain planarity. If all carbons are sp2, sp is planar or not? sp2 is also planar. sp2 also planar. If molecule carry all sp2, it is planar. But here all sp2 or not? Yes. Even though this molecule having all sp2 carbons, but this is not a planar molecule due to presence of proper availability in a tub form. It is a tub shaped molecule. It is not a planar molecule. So due to more number of carbons, this molecule shows a non-planar arrangement. It is not planar. Okay, this is non-planar due to more number of carbons and availability in stable form. Tub shape structure. See, all aromatic molecules are planar, non-planar, option C, linear, option D, both A and C. All aromatic molecules are planar, they are not linear. Every aromatic molecule is planar. Aromatic molecules are diamagnetic in nature. So this point you remember, they are stable and diamagnetic. They are found to be stable and diamagnetic. Aromatic molecules are diamagnetic. So they are having a paired arrangement of electrons. This point remember, there is no unpaired electron in aromatic molecules. If I say the word aromatic, remember they are stable. They are diamagnetic. There is no unpaired electron in their molecular orbitals. It will come in concept of aromaticity. Even in quantum chemistry also it will come. This point you remember, every aromatic molecule having a paired arrangement of electrons in their molecular orbitals. It is impossible to write an unpaired electron in their molecular orbital for aromatic molecules. This point you remember, they are diamagnetic in nature, they are stable and they are having a paired arrangement of electrons. Paired electrons are there everywhere. Suppose if 10 electrons are there, 10 will be paired. 8 electrons, 8 will be paired. 6 electrons, 6 will be paired. So ultimately, they never carry odd number of electrons. Simple. If they carry even number of electrons, they should be paired. Benzene, how many electrons are there? How many are delocalizing? 6. 4n plus 2 rule if you apply, you will get 6 electron, 10 electron, 14, 18 like that. See, all are even numbers or not? Simple strategy. Okay, so while you are filling electrons in their corresponding molecular orbital energy levels, they never carry at least one unpaired electron for diamagnetic molecules, especially aromatic. Every aromatic molecule is diamagnetic. So you should know and you should identify whether it is aromatic or not. Every aromatic molecule is planar, every aromatic molecule is diamagnetic, they are having paired arrangement of electrons and they are found to be stable. That's why if you see naphthalene if you see, can you experience that smell of naphthalene? Yes. But its lifetime will be very high. They never disappear on the spot. What is the meaning of aromatic? Aroma. Aroma nothing but pleasant smell. Okay, they will give pleasant smell, lifetime will be very high. So take a bunch of naphthalene balls, place in your house for a particular place, anywhere you place. But see, after 10 days, still they survive or not? Lifetime is very high or not? Stable. Suppose if you take any liquid, if you place somewhere else, that will disappear out. Okay, suppose any fragrance if you take, that fragments without consuming any heat energy. If they disappears, it will take much more time. That is called aromatic. Aromatic nothing but pleasant smelling compounds which are involved in EPS reaction. They are called aromatic. Clear? Here also same. Next. All anti-aromatic molecules are planar, non-planar, C. Linear, same. C and D, C, B and C. B and C both are possible. Both B and C, same. Both A and C options are correct. All anti-aromatic molecules are. Anti-aromatic molecules also planar. Aromatic is planar. Anti-aromatic is also planar. Aromatic is sp2. Anti-aromatic is also sp2. But difference is anti-aromatic molecules are unstable. They are stable. They are anti-aromatic. They are aromatic. They have unpaired electron. They don't have unpaired electron. That is general filling paid property of this one. So I can say anti-aromatic molecules are paramagnetic. Anti-aromatic molecules are paramagnetic. And this is found to be unstable. Okay, so if it is unstable means you will get unpaired electron or paired electron. So definitely unpaired electron is present. So many unpaired electrons are present. If I say anti-aromatic, delocalization increase energy. Delocalization, see electrons are revolving in benzene or not? See if I take one example for aromatic molecule, benzene. Benzene 6 electrons are delocalizing, right? Here 6 electrons are there. When the 6 electrons are delocalizing, what happens to energy of benzene? What happens to energy of benzene? If electrons are delocalizing, what happens to energy of molecule? Loses or gains? See, just assume that you are standing here. Suppose whenever if you are continuously running, whether you will lose energy or gain energy? Lose energy, simple. When you lose energy, whether you are stable or unstable? Stable or unstable? If you lose energy, stable or unstable? Unstable or stable? Stable. Can you move? No. If you run continuously, after running, will you stand? You will lose your complete energy, you are stable. Stable nothing but unable to move. Suppose if you are doing exercise continuously, finally what happens? Your energy will be loosed. You required energy or not? Means you are losing your energy. When you lose your energy, what is your ultimate target? You become a stable species. You are converting into stable. Right or not? See, I will give one more example. Here this is 5 kilometers are there. Here also 5 kilometers. And here also 5 kilometers distance is there. 5k run. One person is running from here. Okay, here one more person. 3 persons are completing this run. 3 persons are participating in this competition. Distance is how much? 5 kilometers. Okay. So this person completed within 1 minute. This person completed within 30 minutes. This person taken nearly 6 hours to complete. This person completed 5k run within 1 minute. And here 30 minutes he was taken to complete the 5 kilometers run. Distance same or not? But what about time? Time is very less. Time increases. Time is more increases. Now, which person is stable after completion of run? Which person is stable after completion of run? Which person is stable? First person, second person, or third person? Which person is stable? See, if this person run 5 kilometers within 1 minute, whether he will survive, whether he will live or die. If you see constable competitions will be there sometimes, SI or constable, some people unable to run. Middle of the competition only they want to drop because they attain stability very fastly. After completion of this person, after within 1 minute if they complete, they loses their complete energy. Person will not stay, he will die. That is stable. But here he can stand little bit, 30 minutes. But this person, he was ready to compete one more time. After 6 hours, this person can ready to participate in competition one more time. Why? After completion of 5k run, this person not uses its own total energy. He was using less energy. Still this person will have some energy or not? This person having energy means he was unstable. Okay? So, whenever if you are using more amount of energy for any work, you will attain stability. Suppose if you are spending less amount of energy, then you become unstable still. You have a ability to do some work. Right or not? Okay, here also same. When benzene electrons are delocalizing within the ring, benzene electrons loses energy. When energy loses, molecule become relaxed because it is losing energy. Finally it will be relaxed. You know activation energy, activation to ground state, same process. Anti-aromatic is not like that. Quite opposite. Anti-aromatic, delocalization increase speed. Here delocalization decrease energy, there delocalization increase energy. There is a difference between aromatic and anti-aromatic. In aromatic molecule 100% behaves like a humans. Aromatic molecule behaves like a humans. If you do one particular work continuously, you need some rest or not? Because you are attaining stability, you are losing energy. But anti-aromatic molecules are not like that. If they do any work, speed increases. Speed increases means energy is not going outside. Energy is taken by the molecule only. Delocalization increase energy. When you run, your energy increases. When you run, your energy loses. That is aromatic. When you run, if your energy increases, then energy, see, suppose this is your 5k run. Just try to observe this. One person is running here. So whenever if you run, first you have, before starting of this competition, you have more energy or not? So on that time you will run very fastly or not? First you will run very fastly, then you will drop your energy like this. Why your energy drops? Why energy drops? Because initially you are using more amount of energy. When energy decreases in body, automatically your speed is also increases. Speed increases or decreases? Decreases. Speed decreases. When energy decreases, speed decreases. Simple. But anti-aromatic molecule are not like that. First they will start very slowly, then they will increase the speed. Slow, then fast. They are first fast, then slow. What is the difference? Aromatic molecule loses energy slowly, but anti-aromatic molecule gain energy slowly. Losing is different, gaining is different. There is a difference. So that's why anti-aromatic, aromatic both are quite opposite. So don't think that anti-aromatic molecules are stable. Anti-aromatic is highly unstable as compared to aromatic. Aromatic is stable always. So that is about planarity and linearity. Is it linked with hybridization or not? Yes. If you know the concept of hybridization, maximum concepts will be very easy for you. That is the advantage of hybridization. Next, after linearity, planarity, then try to learn about types of carbons. Keep heading types of carbons. How many types of carbons are present? Types of carbons. How many types of carbons are present? Total 5 types of carbons are present. Super primary, primary, secondary, tertiary and quaternary. What is super primary? What is the valence of carbon? Valence of carbon is 4. So when carbon attaches to 4 hydrogens, that is called super primary. No other carbon will be attached. If carbon attaches to one other carbon, primary. If carbon attaches to 2 other carbons, secondary. 3 other, tertiary, 4 other, quaternary. So how many hydrogens are present on super primary? How many hydrogens present on super primary? 4. Carbon never attaches to one other carbon. That is called super primary. What is primary? Carbon attaches to one other carbon. First carbon attaches to other carbon, then this carbon remaining balance with hydrogen. Then how many hydrogens are present on primary carbon? 3. Clear? What about secondary carbon? Carbon attaches to 2 other carbons. Secondary carbon carry how many hydrogens? 2. Secondary carry 2 hydrogen. Tertiary carbon. Carbon attaches to 3 other carbons. Tertiary carry how many hydrogens? 1. Quaternary? No hydrogen. Super primary carry 4 hydrogens. Quaternary carry no hydrogen. Clear? Right. Take note. They are classified into 5 types. Types of carbons. They are classified into 5 types. First one, super primary carbon. Write directly, super primary carbon. Super primary carbon. Right. Carbon attaches to only hydrogens. Carbon attaches to only hydrogens. Carbon attaches to only hydrogens. Only hydrogens. Can you give an example? CH4. Only one example is there, CH4. Carbon attaches to only hydrogens. That is super primary. Then primary carbon. Primary carbon. What is primary? Carbon attaches to one another carbon. Carbon attached to one another carbon. Carbon attaches to one another carbon. This is CH3, CH3. So this is primary, it is also primary. Secondary carbon. Will you define what is secondary? Carbon attaches to two another carbons. Carbon attached to two another carbons. So can I write like this? CH3, CH2 and here one more CH3. So what is this? Is this carbon attaches to two other? So it is a secondary. What is this? Primary, primary. Suppose if I take this molecule CH3, CH2, CH2, CH3. Is this carbon attaches to two other carbons? Yes, it is secondary. Here, secondary. What is this? Primary, here primary. The hydrogens present on secondary carbon is called secondary hydrogen. The hydrogen present on primary carbon is called primary hydrogen. You focus on hydrogens every time. Next, tertiary carbon. What is tertiary carbon? Carbon attaches to 3 other carbons. Carbon attached to 3 other carbons. Carbon attaches to 3 other carbons. How many hydrogens present on tertiary carbon? 1 hydrogen. So what is this carbon? Primary. This one primary. What is this? Tertiary. This one tertiary. Tertiary or primary? This is primary. Don't confuse. Tertiary carbon carry how many hydrogens? 1. In this molecule, how many primary hydrogens are present? In this molecule, how many primary hydrogens are present? 9. Like that I will ask questions. In this, how many secondary hydrogens are present? 4. How many primary hydrogens are present? How many secondary carbons are present? 2. Primary carbons. 2. Primary carbons. 3. Secondary carbons. No secondary carbon here. Okay? No secondary carbon. Here carbon, CH3, CH, CH, CH3, and here one more CH3 I'm writing. How many tertiary carbons are present here? Tertiary, tertiary. How many primary? 4 primary carbons. How many primary hydrogens? 12. How many tertiary carbon hydrogens? 2. Like that clear statement they will give. A molecule with a molecular formula carry only tertiary carbon hydrogens. Identify the molecule or give the molecule structure. It will help in spectroscopy, this concept. So now quaternary carbon. Quaternary carbon. What is quaternary? Carbon attaches to 4 other carbons. Right. Carbon attached to 4 another carbons. CH3, CH3, and here one more CH3. This is quaternary. Quaternary carry how many hydrogens? No hydrogen. Right. Take one question. The number of primary carbons present in 2,3 dimethyl pentane is how many primary carbons present in 2,3 dimethyl pentane? The number of primary carbons present in 2,3 dimethyl pentane. 4 or not? Answer is 4. So if you know the structure, answer is clear. So this is second carbon and here it is a third carbon. 2,3 and this is fourth and this is 5. 1, 2, 3, 4 and this is 5. Second carbon carry methyl, third carbon carry methyl, 2,3 dimethyl pentane. So this is 1, 2, 3, 4. Every CH3 become primary. Primary, 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 primary. Total 4. Which of the following molecule have only primary carbons? Two comma 3 dimethyl butane. Two comma 2, 3 comma 3. Tetramethyl butane. Ethane. D. Propane. So option E all. Which will carry only primary carbons? What is the answer? Answer is C. Ethane. So in this any primary carbon is there? 2,3 dimethyl butane, any primary carbon is there? Yes, primary carbon is there, but what is the drawback? Additionally, tertiary carbon is also there. That's why this option is not exist. What is the question? Molecule should carry only primary carbon. They should not carry other carbons. Here primary, tertiary, but what about here? Primary, quaternary. Primary, quaternary. Here only primary. And here primary and secondary. The molecule having only primary hydrogens are. The molecule having only primary hydrogens are. That is ethane, 2,2, 3,3. Tetramethyl butane, 2,2 dimethyl propane, option D all. The molecule having only primary hydrogens are. Which one? Answer is all. This is not carbon. Primary carbon is different, primary hydrogen is different. See, if I write a molecule, in that only hydrogen should be primary. See this, ethane. Here how many hydrogens are there? 6. Total how many hydrogens? 6. Is it 6 hydrogens are primary? 6 hydrogens are primary or not? Yes, they have all primary. Now, if you see this molecule, is this molecule is this 2 comma 2 3 comma 3 tetramethyl butane, right? 2 comma 2 3 comma 3 tetramethyl butane. 2 comma 2 3 comma 3 tetramethyl butane. Here how many hydrogens are present? 18, right? Is it 18 hydrogens are primary? I am not asking carbons. They may carry quaternary, but quaternary we know there is no hydrogen. So 18 hydrogens are there, 18 are primary. Okay, it is also matching. Now this one, see, propane. Here if I take 2 comma 2 dimethyl propane, in this how many methyl hydrogens are present? 12 or not? Is it 12 hydrogens are primary? Yes, primary hydrogens. I am not asking primary carbon. Suppose if I ask the molecule having only primary carbon, which option is correct? A. There is a difference. If they carry only primary carbon, this is the correct option. If they carry primary hydrogen, all having primary, we know quaternary having no hydrogen. That's why these options also include in this one. That's why you need to see option clearly. Give a set of molecules having sp3 carbons with primary hydrogens. Give a set of molecules having sp3 carbon with primary hydrogens. Give the answer. What is the question? They should carry what type of carbon? sp3. They should carry sp3 and they should carry only primary hydrogens. Can I take these all examples? Yes. Can I take ethane? So can I take propane, dimethyl propane? Here methyl and here one more methyl and this is one more methyl. Can I take tetramethyl butane or not? Same example I am repeating, right? Can I take propane? No, they have sp3 carbon but they have secondary hydrogen. So don't take propane. Clear? Give a set of molecules having sp3 carbon with only secondary hydrogens. Give a set of molecules having sp3 carbons with only secondary hydrogens. Iso? Primary carbon is there na in that one? They should not carry primary. They should carry only secondary. Can I take cyclopropane, cyclopropane, cyclobutane, cyclopentane, cyclohexane, etc. All having secondary hydrogens only. Any primary? All having sp3 or not? Each and every carbon is sp3, all having secondary carbon hydrogens. Give a molecule with sp3 carbons having only tertiary hydrogens. What is the hybridization of all carbons in this? Hybridization of all carbons, sp3. Suppose if you take 4 carbons, 4 should be sp3. If they carry 5, 5 should be sp3. But if hydrogens are present, that hydrogen should be tertiary. Try to understand the question. Here what are the hydrogens? Secondary. What is the hybridization of carbons? Hybridization of carbons is sp3. Each and every carbon having sp3, they should carry only secondary. Matching? All carbons are sp3 and each and every hydrogen should be secondary only. They never carry primary, never carry tertiary, etc. And here what I am asking? They carry sp3 carbons. All are sp3. But they should carry tertiary hydrogens only. They never carry secondary, never carry primary, like that. You can take quaternary carbon because quaternary carbon having no hydrogen. So create that molecule. So that molecule I will reveal after the break. Okay, take a small break. So within 5 minutes we will be back to the class. Okay, take a break. So can you give a molecule having sp3 carbons having only tertiary hydrogens? So they should not carry secondary, primary, etc. So can I take this one? Here 3 carbons I am writing and here I am joining these 3. So here 1 hydrogen, here 1 hydrogen, and here 1 hydrogen, and here 1 more hydrogen. How many hydrogens are present? In this molecule, how many hydrogens are present? 4. 4 hydrogens are belongs to which one? Tertiary. What is hybridization? sp3. Any hydrogen belongs to primary, secondary? No. So one more example you can write. See, write down all carbons So join them. So this carbon tetravalence I would like to create, and here it is hydrogen, and here hydrogen, 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 like that. How many carbons? 5. But we don't want carbons. We want only hydrogens. That too tertiary hydrogens. How many tertiary hydrogens? 1, 2, 3, 4. Matching. 4 hydrogens are there, but all hydrogens are belongs to tertiary. Like that you need to create structures. It may help in spectroscopy if you know this concept clearly. A molecule with a molecular formula C5H4. Molecular formula is C5H4 having only tertiary hydrogens. Give it structure. What is the answer? This one only. Same answer. Formula matching, hydrogens matching, but hydrogens all are tertiary. Same answer already given. Yes. Right. Repeat this question one more time. A molecule with a molecular formula C4H6 having secondary and tertiary hydrogens only. Give it structure. Molecular formula is C4H6. Okay? Formula given, molecular formula. In that, what I am saying, they carry only secondary and tertiary hydrogens. They should not carry primary hydrogens. Give the structure. So this is CH2 CH, and this is CH, and this is CH2. So this two will be joined together. What is this hydrogen? Tertiary, tertiary, secondary, and this is secondary. Is there any primary? No, no primary. And see, if I take carbon-carbon double bond, remember, even double bond is present, we can also apply primary, secondary, etc. Suppose this molecule is 1,3 butadiene or not. Now, what type of carbon it is? Is this carbon attaches to 2 times to this one? So now it is a secondary. Is this carbon attaches to 3 times to this 2? This carbon attaches to 2 times left side, 1 time right side. So now it is a tertiary. This one, it is also tertiary. This carbon attaches 2 times right side, 1 time this side. 3 carbons. Right? It is tertiary. What is this? Secondary. So one more example I will give. See, if I write CH2 carbon-carbon double bond, carbon-carbon triple bond H. Now it is which carbon? Secondary. This one? Tertiary. This one? Quaternary. See, right side 3 carbons, left side 1 carbon. Then what about this one? Tertiary. Is it clear? Suppose if I give this molecule, this is called camphor. Camphor. So what type of carbons they have? See, what is this carbon? Secondary, secondary, tertiary, secondary, quaternary. What is this? Quaternary. This one. Here, primary, primary. This one, primary. This one, secondary. This is secondary. Okay. So you need to identify the types of carbons in variable skeleton. This is called alpha pinene. You remember this name? Alpha pinene. Can you identify the carbons? What is this? Tertiary, secondary, tertiary, quaternary, primary, primary, primary. Here, secondary. What is this carbon? This is quaternary. This one, tertiary. Okay. Suppose, see, one more example I will give. This is CH, and this is CH3, and here one more CH3. Now this is attaches to OH. Now this is which carbon? It is a secondary carbon. OH attaches to secondary carbon, that's why it is secondary alcohol. Clear? Secondary alcohol. Suppose if I write this alcohol, this is CH3, and this is CH3, and this is OH. Now this is which carbon? This is a tertiary carbon. How many primary is there? Primary, primary, primary. Now, if you observe clearly, this is CH3, CH2OH. Now this is CH3, and this is CH3. It is which alcohol? What is this carbon? Quaternary. Primary, primary, primary. What is this? Primary or not? Now it is which alcohol? Primary alcohol. OH is attaches to primary carbon or not? OH attaches to primary carbon. This is primary alcohol. Now OH attaches to tertiary carbon, tertiary alcohol. Like that alcohols are classified. Identify the carbons. What type of carbons they have? What type of carbon it is? Secondary. This one quaternary. Here quaternary. Here tertiary. This is primary. Okay. Here what is this? Quaternary. Quaternary. This one tertiary. Tertiary. Now this carbon quaternary. This one now it is secondary. Now this is quaternary. This one tertiary. 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 This is also tertiary. Tertiary. This one, this carbon tertiary. Tertiary. So you can identify the carbons clearly. What type of carbon they have actually. Based on other carbons, we are classifying the carbons. That's it. Don't see other elements. Hydrogen, oxygen, nitrogen, sulfur like that should not be considered. Only consider other carbons only. You take this question. A molecule with a molecular formula C8H18. A molecule with a molecular formula C8H18 produce primary all types of carbons. All types of carbons. Give it structure. So I am saying that primary, secondary, tertiary, quaternary carbons are present, but not super primary. Remember, when you write super primary, we can't write other carbons. Super primary, only separate molecule you can write. So don't include super primary. In this molecule C8H18, you have all types of carbons such as primary, secondary, tertiary, quaternary, minimum 1 carbon. You need to create a structure such a way that in this formula they should carry primary, secondary, tertiary and quaternary, minimum 1 carbon, and overall this formula and hydrogen should match. Can you create the structure? How many carbons are present? 8 carbons or not? So here see, up to here how many carbons are over? 4 carbons or not? 4. And this is 5th carbon, 6th carbon, 7th carbon, and this is 8th carbon. So what is this carbon? Primary. This one? Tertiary. Secondary, quaternary. Is it matching this formula? 8 carbons are there or not? 4, 5, 6, 7, 8. 8 carbons are there, 18 hydrogens are there. In this primary, secondary, tertiary, quaternary, all carbons are present. So one may be heavier, other may be less. That is not going to be considered. Simply consider minimum 1 primary, secondary, 1 tertiary, 1 quaternary. Minimum 1, 1. All are there or not? Yes. Isooctane. Molecule name is isooctane. So that is types of carbons. Next topic, degree of unsaturation. Du. It is represented by du. Degree of unsaturation. Very, very important topic. After knowing carbons, you will understand this clearly if you identify the type of carbons within the molecule. Degree of unsaturation. So what is unsaturation? What is unsaturation? Double bond or triple bond. Even one ring. If any molecule having ring, if any molecule having double bond, triple bond, then that molecule is said to be unsaturated. Don't think that only double bond, if it is present, it is unsaturated. Unsaturated nothing but unsatisfaction. Right or not? When you are unsatisfied, will you stable or unstable? Unstable. Here also unstable. Unsaturated molecules are unstable. If you are unstable, more reactive or less reactive? More reactive. Here also they are more reactive. That's why double bond, triple bonds are more reactive than single bond. Clear? So, unsatisfaction of a molecule is expressed in terms of du. Suppose one molecule is unsatisfied. How much it is unsatisfied? That we want to measure. Humans we can't measure. Because we are lifelong unsatisfied only. Right or not? Okay? But molecules, one limit is there. We can measure unsatisfaction of a molecule. How much it is unsatisfied, that is expressed in terms of du. Degree of unsaturation means how much it is unsatisfied. How to make them satisfied? Will you satisfy? Anywhere? No. If you satisfy, you won't come here. After cracking JRF also, you won't satisfy. After getting job also, you won't satisfy. Okay? So, everywhere who is unsatisfied person? Humans are unsatisfied anywhere. Even if you got a good job, even if you got a JRF, suppose in your 10th class, you will think that once if 10th class is over, everything is clear. But then your parents thinking about MPC, BPC, then unsaturation comes. So once if you think that, once if MPC is over, life is close. Then on the time they are going for IIT, G, mains, like that different entrances. Then you people become highly unsaturated. Then after getting engineering rank, without engineering rank, then question about which engineering college you are going to get in counseling. That is also unsaturated. After successfully completion of your engineering, getting 4th year, so in 4th year facing interview, that is also unsaturation, unsatisfied, whether you will get or rank. After cracking job, still you are unsatisfied. Then after, why? Because next is marriage. After marriage also unsatisfied. So who is unsatisfied people? Humans are, so there is no measurement is there to measure unsatisfaction of a humans. We can measure unsatisfaction of a molecule. So this is the general technique to identify how much a molecule is unsatisfied. So can you make them satisfy? Yes. If you are measuring means, you can make them satisfy. If you are not measuring means, impossible to satisfy. Can you satisfy a person? Lifelong can you satisfy a person? No. Impossible. Because situation changes, unsatisfaction also changes. Right or not? Here also same. But molecules are not like that. Converting triple bond to single bond. Converting double bond to single bond. Converting any ring to open chain. So finally what is the target? Any molecule want to reach? Any molecule want to reach saturated. See, remove this unsaturated. And if you remove, what is this? Saturation. What is the meaning of saturation? Converting into single bond. Any molecule converts into single bond, that is its target. Okay? That's why alkanes, ultimately every molecule want to reach up to alkane. Why alkane? Alkanes are saturated. They are satisfied species. That's why see, alkane chemical reactions are not much more. Even in your intermediate degree, whatever it may be, see the alkane chemical reactions. You won't expect much more because they are satisfied. They are already satisfied, that's why they won't participate in chemical reaction. If you go through alkene, see the chemical reactions of alkene. Alkene is unstable, unsaturated. Reaction with HBr, Markovnikov rule, anti-Markovnikov rule, Sage-Jeff rule. Okay, addition of HBr, HCl, bromine, chlorine, HOBr. Then addition of mercury dichloride, addition of acid, ozonolysis, what not, many reactions are there. Everywhere what we are breaking in alkene, pi bond we are breaking. Why we are breaking pi bond? Because when you break a pi bond, leftover bond is sigma bond. Sigma bond is nothing but alkane. Ultimate target of any molecule is what? Ultimate target of any molecule, they want to reach up to alkane. Because unsaturated to saturate. That is our target. Okay. So then what is alkane general formula? So I want to reach, or any molecule want to reach alkane general. In generally they want to reach alkane. So what is alkane general formula? CnH2n plus 2. If any molecule reaches CnH2n plus 2, then that molecule is said to be saturated. How many hydrogens are less than alkane general formula? That is called du. Suppose if 2 hydrogens are less than alkane general formula, 1 degree of unsaturation. 4, second degree. 6 third degree, 8 fourth degree, like that. Okay, right. Write the definition. Unsaturation or unsatisfaction. Unsaturation or unsatisfaction. Unsaturation or unsatisfaction of a molecule expressed in terms of unsaturation or unsatisfaction of a molecule expressed in terms of degree of unsaturation, du. Next, the number of hydrogens less than alkane general formula. The number of hydrogens less than alkane general formula is du. Alkane general formula is du. So here you write alkane general formula CnH2n plus 2. What is N indicates? Number of carbons. N is equal to any integer. You can substitute any integer. Suppose if I substitute 1, CH4. If I substitute 2, if I substitute 2 here, C2, 2 into 2, 4 plus 2, 6. N is equal to any integer. Okay, CnH2n plus 2. Right. If two hydrogens less than alkane general formula, then du is equal to 1. If two hydrogens less than alkane general formula, d is equal to 1. When d is equal to 1, molecule may carry, if d is equal to 1, may carry one double bond or may carry one ring. You remember this point. If du 1 means, what it means? 1. If degree of unsaturation 1 indicates they carry one double bond or one ring. One ring is equal to 1 du. One double bond is equal to 1 du. Double bond nothing but pi bond. Okay? Every double bond nothing but every pi bond. Every pi bond 1 du. Every ring is also 1 du. Here if I write 1 indicates that du 1 indicates that they carry one double bond or they may carry one ring. Okay? Next. If 4 hydrogens less than alkane general formula, degree of unsaturation is what? 2. 2 means what? 2 double bonds or 2 rings or 1 triple bond. 1 triple bond carry how many pi bonds? 2. 1 triple bond, what is the du? 2. Okay? So you may expect 1 double bond plus 1 ring. Like that all possibilities you can expect. Can you guess? If 6 hydrogens are less than alkane general formula, what about du? Du is equal to 3. If 6 hydrogens less than alkane general formula, then what will you expect? 3 double bonds, 3 rings, then how many triple bonds? Can you expect 1 triple bond or not? 1 triple bond plus 1 double bond. Possible? In triple bond, how many pi bonds are there? 2. In double bond, how many pi bonds are there? 1. 2 plus 1. Okay? So, can I write 2 double bonds plus 1 ring? Possible? 2 double bond, 1 ring. 2 double bond means how many pi bonds? 2 pi bond. 1 ring means 1 du. 2 plus 1, 3. Total number of pi bonds, total number of rings should reach up to 3. Clear? If 8 hydrogens less than alkane general formula, Then du is equal to how much? 4. So what is 4 indicates? Can I say 4 double bonds? 4 double bonds, 4 rings, 2 triple bond, 1 triple bond plus 2 double bond, like that. Many possibilities are there. Not only this, you can create many. Every pi bond is equal to how much? Every pi bond. Every pi bond is 1 du. Every ring 1 du. In double bond, how many pi bonds are there? 1. In triple bond, how many pi bonds are there? 2. Every triple bond is equal to 2 du. Every ring is equal to 1 du. So that's why, see, I want to create 2. Degree of unsaturation 2 means 2 pi bonds I want. 2 pi bonds means I can take 2 separate pi bonds, 1 triple bond. Otherwise 2 rings, 1 ring, 1 double bond. Clear? You need to identify this logic. This is creativity. It is also comes one more time in mass spectrometry. Ring rule. You know, nitrogen rule is there. One nitrogen rule in mass spectrometry. Okay. So if you know this one, mass spectrometry help to determine the structure very easily. Nitrogen rule and this both are same. If you know this point, mass spectrometry is easy for you. Little, especially to identify the molecular formula. 1 du is equal to molecule may carry 1 pi bond. Pi is required. Pi bond is required. Where pi bond is present? In double bond or triple bond. Clear? So du also can be calculated by using this formula. Degree of unsaturation is equal to 2n1 plus 2 minus n2 by 2. You can apply this formula also. If you are unable to remember this, you can use this formula. 2n1 plus 2 minus n2 by 2. n1 is equal to number of carbons, n2 is equal to number of hydrogens. Use this formula, you can get du. 2n1 plus 2 minus n2 by 2. This formula comes one more time in calculation of pi bond. Same formula used in two concepts. First concept du, second concept how to calculate number of pi bonds in a given molecule. So remember this, 2n1 plus 2 minus n2 by 2. So one example I will explain. See this. See, this is C2H4. Right? How to use du I will explain. Two formulas I will explain. See, in this molecule how many carbons are present? How many carbons? 2 carbons. So can I say n is equal to 2? Now try to substitute this 2 in alkane general formula. What is alkane general formula? CnH2n plus 2. If I substitute this 2 in this one, C2, this is C2, 2 into 2, 4 plus 2, 6. Then what is this? C2H6. This is I given. This I given or not? In this what is the carbon number? 2. If that carbon number, if I substitute in alkane general formula, you will get alkane general formula. See the difference in number of hydrogens between these two. Between these two, how many hydrogens are differ? 2. See the formula. If two hydrogens are differ, then what is the du? D is equal to 1. 1 or not? See the formula. 1 du means, how can you write? 1 double bond. See, then forget about this one. This is a formula to calculate only du. After du, ignore this. You focus on this number. Apply this number on this formula. So, between these two carbons, can I put one double bond? Can you create one ring between two carbons? No. Okay, so that's why first you write down two carbons. Put one double bond here. Okay, du is created. One double bond is equal to 1 du. Then here how many hydrogens are required? 2 hydrogens. Here also 2 hydrogens. Over. This molecule with this structure. Suppose if you apply du formula, you apply this formula for this. How many carbons are present? 2. 2 into 2. 4 plus 2. 6 minus 4. 6 minus 4 how much? 2. 2 by 2. 1. You will get this number. You can apply this formula, otherwise direct alkane general formula. So one more I will give. Just wait. Don't write. See, I am giving C4H6. C4H6. Now, what is N? What is N here? N is equal to 4. If N is equal to 4, apply alkane general formula. CnH2n plus 6. CnH2n plus 2. So, C4, 2 into 4, 8 plus 2. C4H10 or not? So, here actually H6. When 4 carbons are present, alkane is saying that I need 10 hydrogens. But this carry only 6 hydrogens. Means how many hydrogens are differ? 4. 4 means what is the du? Du2. Du2 means what it means? So, can you apply in this formula? 2 into 2. 2 into 4. This is a molecular formula or not? 2 into 4. 8 plus 2. 10. 10 minus 6. 4 by 2. You will get 2. 2 means what? 2 double bonds. So, see how to create 2 double bonds. See how many carbons are there? 4. 1, 2, 3, 4. Can I put 2 double bonds? Anywhere you can put 2 double bonds. So, see I am putting double bond here and here. Balance with hydrogens. How many hydrogens required? 2. Here 1 hydrogen. Here 1 hydrogen. And here 2. Automatically this formula matches to this. Suppose one more I will show. 1, 2, 3, 4. Du. Can I write one triple bond? Can I write one triple bond or not? Yes, see. If I write triple bond anywhere, this is triple bond. Here how many hydrogens are required? 3. And here 3. Matching formula? C4, H6. Anyone? Can you create one ring? One ring or one ring plus one double bond? See, degree of unsaturation 2 means can you create 2 rings? Can you create 2 rings or not? So, I am going to create 2 rings here. See, this is how many carbon? How many carbon? 4 carbon. I want to create 2 rings. Here, how many rings are over? 1. With 4 carbons, we need to create 2 rings. If I write one line here, over. See the formula. Here, how many carbon? Hydrogens? 1. 1. Here, 2, 2. 2, 4, 5, 6. 4 carbon. C4H6. One ring, one double bond. Possible? This is one ring. One double bond. Can I write one double bond here anywhere? Formula matching, see? No need to check. If you know that number clearly, automatically molecular formula will match. Suppose one more example I will give. See, I am creating one ring. 4 carbons over? 4 carbons over or not? No. So here if I write one methyl, 4 carbons over? But du matching? Du matching or not? No. What is the du? For C4H6, what is the du? Du2. In this du2, I written one ring. 4 carbons is over. 4 carbons is over. Du, one ring, one double bond. One ring, one double bond. So I can put one double bond outside or inside, anywhere you can put. Is it Du matching? Focus on carbons and Du, automatically hydrogens will follow. No need to see hydrogens. C4H6, what is the Du? 2. So how many carbons are present? 4. Then take 4 carbons. Create one ring, one double bond. Automatically hydrogens will come. Clear? This is a way of creating a molecule based on mass spectrometry, based on fragmentation, we can determine the structure. That is the ring rule actually. Clear? Take that. What is C6H6? What is C6H6? Benzene. What is C4H8? What is C4H6? C4H6. Which molecule you will say? C4H6. C4H6, how many molecules are possible? These all are possible. C6H6, which molecule is possible? Try to understand what I am asking. C6H6 is not benzene every time. If C6H6 is benzene means, then you should say C4H6, some famous molecule. In your studies, what they given is, everywhere whenever if you are learning C6H6, C6H6 continuously, they given such a way that everywhere that is belongs to only benzene. That is not benzene every time. Many family members are there. In that only benzene is top. Because it is more familiar for you. Remaining molecules are not familiar. That's why you are unable to give structure of other molecules. So what is the molecular formula of this one? C4H6. Molecular formula? C4H6, C4H6, C4H6. So I will show one example. Take C6H6. What is N here? 6. What is alkane general formula? CnH2n plus 2. Then if I substitute 6 here, C6, is it 14? How many hydrogens are differ between these two? Between these two, how many hydrogens are differ? 8 or not? 8 means what is the du? Du is equal to 4. Otherwise apply du formula. Degree of unsaturation is equal to 2 into n1 plus 2 minus 6 by 2. How much you will get? 12 plus 2, 14. 14 minus 6, 8 by 2. 8 by 2 means what? You will get 4. You can apply like this also. Now what is 4 indicates? Can I write 4 double bonds with carbon? Du4 means what? 4 double bond. How many carbons should I take? Maximum how many carbons? 6 only. Take 6 carbons. Remember. 2, 3, 4, 5, 6. 6 carbons I taken. Right? Can I put 4 double bonds? See, here double bond. Here one more double bond. Here double bond. And here double bond. See the formula. Here how many, total how many carbons? See the hydrogens. Here how many hydrogens? 2. Here? No hydrogen. Here? 1. Here? 1. No hydrogen? 2 hydrogens. 2 plus 1, 3. 2 plus 1, 3. Total. C6? H6 or not? Okay. Then one more molecule I will give. See, 2, 4, 6. Now, 1 pi bond, 1 double bond, 2 double bond, 1 triple bond I am taking. 1 double bond carry, 1 pi bond. 2 triple bond carry, 2 pi bond. See whether formula matching or not. Du matching. See when you du and carbons match, automatically these hydrogens will come. Here how many hydrogens? 2. 2, 3, 2, 3. Here no hydrogen, no hydrogen. Okay. Now 2, 4, 6. Can I put 1 triple bond here? Here 1 triple bond, here 1 triple bond. Matching? Formula matching or not? C6S6, C6S6 or not? C6S6. Okay. Now I will give one more. See, I would like to create 4 rings with 6 carbons. Possible? 4 rings I want to create. With how many carbons? 6 carbons. See this. See, here how many carbons are present in this one? 4 carbons. What is our target? 6 carbons. 6 carbons are there? No. So, here if I write one more, how many carbons? 6. Du matching? In these 6 carbons, du matching? No. What is the du in this one? What is the du in this one? 2. Du not matching, but carbons matching. Until du matches, hydrogens never follow. Carbons and du should match. Then, if I write one ring here, and if I write one more ring here, is it matching? Total how many rings? 4 rings. How many carbons? If du number of carbons matches, no need to see hydrogens. Automatically they will come. See, 1, 2, 3, 4, 5, 6 carbons are matching. Now here how many hydrogens? 1. Here 2. Here no hydrogen. Here how many hydrogen? No hydrogen. Here 1 hydrogen, 2 hydrogen. 2, 1, 3, 2, 1, 3, 6. Now see this. What is the du of this molecule? Du 1, du 2. Carbons matching? Carbon 6 or not? Now I am putting one double bond and double bond here. Matching? 2 double bond, 2 rings. Right or not? 2 double bonds, 2 rings. See, 6 carbons, 1 double bond, 1 ring. Okay? Can I create 2 rings? 2 rings already created. This is 2 rings or not? 2 rings? 2 rings like that. Can I create 3 rings? 3 rings. 3 rings, 1 double bond. 3 rings, 1, 2, 3, 1 double bond. Can I create 1 ring? 1 ring, 3 double bond possible? 1 plus 3 how much? What is du? 1 ring, 3 double bond. Total how much? So 1 ring means what should I create? Can I create 1 ring like this? Can I create 3 double bond? So don't think that it is belongs to benzene. Benzene is one of the member. But why we are saying C6H6 means benzene? Because it is most familiar for you. That's why you're saying benzene. But what about remaining molecules? What they will think? This molecular formula belongs to all molecules. Don't say C6H6 is benzene. Right? C6H6 is generally a molecular formula for mixture of isomers in which one of the molecule is benzene. Suppose see, can I create a 5-membered ring? This is 5-membered. Carbons matching? No. Put one carbon outside. Du matching? Carbons matching or not? Du matching? Du matching or not? No. How much do you right now? How much do you? 1. Still 3 is required or not? So put one double bond here, double bond here, double bond here. Fulvene, fulvalene, calcine, this all you can also express over here. You know dibarbenzene, same formula. Prismine, same formula. Suppose say I want to take a 3-membered ring. See, here 3-membered ring, 3-membered ring. How many carbons? 6 carbons or not? Du matching? No. So I would like to put double bond, double bond. Matching du? Then count the formula. C6H6 will come. Like that you can create many structures. Many structures. So in your sample which structure is correct, that can be verified by spectroscopy. In your sample you will get this formula. Based on any spectroscopy you will get this formula. C6H6 or you are getting C6H6. So your guide is saying that this sample carries C6H6. Confirm the structure. Don't say benzene on the time. Sir, C6H6 is there, then why you are saying already benzene is there means it is not benzene. Many molecules will come. We don't know which molecule it is. So when C6H6 is the molecular formula based on stoichiometric analysis, once you confirm that they carry 4 carbons, 6 carbons, 6 hydrogens, your guide will say that confirm the structure, confirm the molecule, then take mass spectrometry for that, then take HNMR data for that, then take IR data, UV data. Finally you will confirm the structure. So finally start with mass only. This molecular formula comes with mass. I will show you how to calculate the same strategy in mass spectrometry. Clear? Take down. This is calcine. Calcine. This is fulvene. Clear? So take down up to here. So few more examples are there that we will discuss in your next class. Okay, we'll stop here.